Good morning, good afternoon, good evening to everybody. It's Wednesday, June 1st in Pacific Coast US time at least. Welcome to the weekly Cluster API office hours. We abide by the CNCF Code of Conduct, so please use the raise hand feature. Be kind to one another, empathetic, and let's have fun. So I will screen share the should be enough for now. Share. Okay, let me know if I have zoomed in sufficiently. I think that's hopefully big enough. Okay, so here's our date. I'm going to scroll up to the open proposals and we will actually, it's the beginning of the meeting. So that means it's time for anyone who wants to introduce him or herself. Please feel free to unmute right now and say hi and tell us who you are if you'd like, who you work for, anything you'd like to add.
Hi there, my name is Max. I'm working with AWS. We are working on the a new cluster API provider for the infrastructure provider service called Cloud Stack. It's Apache Cloud Stack. We recently just donated our repository, CAPC, to Kubernetes SIG as of over the weekend. And so I am looking to become a member so I can keep working on it. So thank you for the welcoming. And as part of that, I'll need some sponsors. I think maybe Fabrizio or someone else have worked with folks in the past. So yeah, I think I'll keep discussion in the chat.
Cool, cool. Welcome, Max. Yeah, are you on Kubernetes Slack? You can do all those follow-up items in the Cluster API channel there. Yeah.
That's a good call. Thanks.
Great. I see Nawaz, you're raising your hand.
Yep. Hey, everyone. I'm Nawaz. I joined the Cluster API for Azure team recently, and this is my second CAPI meeting. Happy to be here.
Amin, and sorry if I mispronounced your name, you're up.
Yeah, it's correct. Hello, folks. So my name is Amin. I'm from AWS, and I work on open source projects for AWS. I'm very new to Kappa and CAPI, and I'm looking forward to learning more about it and doing few contributions very soon.
Welcome, and welcome, Nawaz.
Hi, Rashid. I just had to keep unmuted. I met a couple of folks who motivated me to join the SIG meetings, and I look forward to contribute to clustering.
Thank you. Welcome, Rashid. Okay, we seem to have reached stable state. Welcome, everyone. Thank you so much for speaking up in front of strangers. We are super excited to see newcomers every week. Okay, great. So the first thing we want to do in this discussion is go through open proposals. So if you'd like to, I'll call them out real quickly. And if you'd like to add a brief status update, please do so. Please make it brief so we can get to our agenda items. So the first one on the list is Spot Instances Proposal Update with Termination Handler Design. Anyone care to add any updates there? All right, Load Balancer Provider.
As far as I'm aware, this has been stale for quite a long time. So I was actually going to add a topic to the agenda to discuss what we want to do with this and see if there's still interest.
That sounds sensible to me. All right, going down the list, Managed External etcd Provider. Moving along to label sync between machine deployments and Kubernetes nodes. Assume that's what K stands for. All right, cluster API add-on orchestration proposal. I know Jonathan's going to give a demo later today.
Fabrizio raised his hand.
Please, Fabrizio, go. Sorry.
So a quick note about level sync. So we had a discussion last week. I promised to take a look, and so I've added a few comments. I think that we are near the finish line, so I suggest the authors to resolve pending comments, address the discussion about extending this proposal to KCP, and then we have to decide if to start immediately the lazy consensus or, as suggested by Cecile, to gate the lazy consensus with at least 2 LGTM. But yeah, for me, we are getting near the finish line for this one. Let's keep going.
Okay, great. So hopefully everybody heard lazy consensus is around the corner. So if you have a stake in the outcome, please go address the comments, add your 2 cents to that proposal. Great. Jonathan, do you want to say anything quickly about add-on orchestration proposal, or is your demo later sufficient?
I think the demo, yeah, we'll be going over it. So
cool. And the last one on the list, manage Kubernetes in CAPI. Anyone here want to add anything? Okay, cool. And Fabrizio, I see that you own a cluster API condition status update with a help wanted note. Is there anything?
No, this is just so first of all, I commented also manage Kubernetes on CAPI, but talking about cluster API condition status update, this is basically a document that tries to summarize all the state of condition across the entire cluster API objects and start a discussion if there could be possible improvement to improve observability, etc., etc., etc. So it is not yet a proposal. It is an area that for me deserves some loves, and so if someone is interested, please take a look.
Makes sense. Okay, going once, going twice on open proposals. All right, here we are, Wednesday, 1st June. So we are at the agenda part. So let's see, looks like the first is the CAPI add-on orchestrator demo. We've got 2 agenda items today, so it's a light meeting. Maybe we'll get some time back. Jonathan, you want to take it over?
yeah, can you give me screen sharing? It says it's disabled for me.
Yeah, if you go in the security tab and make him a co-host, that's usually an easy way to do it. Or you can allow anyone to screen share, which comes with attendant risks, of course.
You're in mute, Jack, if you're talking.
I'm so sorry. I've been, the only thing I see in my tab is allow participants to share screen. I assume that's a general thing. We don't want to do.
Usually what I do is I go in the participant tab, I search for the person, and then and then there is 3 dots, and between this menu there is make cost.
Done. Beautifully taught. Thank you, Fabrizio. Jonathan, I think you're up.
All right, let's see. see if this works. Can I share more than one window?
Yeah, you can
No,
usually like shift click or something like that.
All right, well, I'll give this a try, and then if it doesn't let me, we can try figure something out. But yeah, so today I'm giving a demo of a prototype for an add-on orchestrator for Cluster API. I've been working on this with Jack Francis, and it's a proof of concept of a proposal that Fabrizio wrote. So for a bit of context, there's been a lot of work and discussion on add-ons in Kubernetes, but we're trying to solve a pretty specific problem. So Cluster API lets you manage the lifecycle of any number of workload clusters by applying your CRDs to the management cluster. And often users also need other things like packages on their workload clusters that give them functionality they need, like CNI. But right now, if you want to install packages, you have to like go into your workload clusters and manually install them yourself. And if you need to update it, you need to go back in and update that too. So the goal of this project is to bring packages into the Cluster API lifecycle and allow them to be defined and dynamically configured from the management cluster, which would give us a single point of control. So for this project, we built 2 CRDs and a controller that brings in a package management tool that the user can choose. And just to be clear, we're not defining what an add-on is in this project. We're allowing the user the flexibility to use whatever packages they want to fulfill that purpose. So we're thinking of the package manager a bit like a provider that implements a package management functionality. And we built our prototype using Helm as a reference implementation. So we built a CRD called Helm chart proxy that serves as the user interface and how you would configure your Helm charts, and a second CRD called Helm release proxy for maintaining an inventory of what we've installed. So here's an example of the Helm chart proxy we defined for a cloud provider Azure chart as an example. So first, we have a cluster selector field here that defines a label key and value. And this selector matches any cluster with a matching label and a key value or key and value. So any cluster that matches will have the Helm chart installed on there, and it'll be part of our reconciliation loop. So then after that, we specify the Helm chart with the repo URL, the chart name, and the version. And we also let you specify the release name you want of the installed Helm release. The Helm charts often also need values to be specified for it to work. For example, this chart needs the name of the cluster. And we've made a key value map where you can specify any number of values yourself. We've also added support for Go templating in the value map. So we use this templating so you can fetch configurations from the cluster it's installed on. So for example, if you selected a cluster with the cluster selector, this field will be populated with the name of the cluster, and the CPU limits here, as an example, would be populated with like the control plane replicas +10. And this one's just an example, since you probably wouldn't actually use that. Can you, I think I need to share my terminal now. Do you know if there's a way to share the whole screen?
I don't think this is allowed by the country backs settings. So you have basically stop sharing and sharing the other windows. It is annoying, but it is what it is.
Okay, well, I'll just spin up a new terminal window then.
But you can open the terminal window inside VS Code if you want.
Yeah, no, I had another terminal window set up, but let me see if I can share it.
Yeah, just stop sharing and then start sharing again, and then select your terminal window. Okay.
All right, can you see this?
Yep, looks great.
Cool. So Let me move the screen sharing bar out of the way.
Yeah, and it looks like all the tabs are engaged, so that's good.
All right, so add the controller running another tab. So yeah, we have a controller running locally for this demo, and I can just start it up with make run. And let me get some other tabs going while we wait. So for this demo, I spun up 3 workload clusters called default, machine pool, and Windows. And while we wait for this controller to start, I'm going to apply our cluster label and value to 2 of the clusters, default and Windows. So we have our controller running, and we're going to apply our CRD. And just this is what it looks like, just as a reminder. So what this does is it's going to install our Helm chart on the 2 clusters that we've added our label to. So we can look into those clusters. And so here we're on the default cluster. I've set the kube config. And if we do Helm list, we can see that our chart cloud provider Azure at version 1.23.8 is installed. If we do Helm get values of the chart, we can see that it filled in the cluster name and filled in the CPU limits as 11, which is 1 plus 10 from what we had before, since there's 1 control plane replica. And if we do the same with the Windows cluster, we can see that there's 1 revision and 1 chart. And we can see that it inferred the cluster name or resolved it at runtime here. So another thing we can do is we can remove the cluster label from one of the clusters we've installed it on. So if we do this on the next reconciliation loop, it'll see that the release, we have a release we installed on a cluster that's no longer selected, and we consider that release to be quote unquote orphaned, which means on the next loop, we will uninstall it from the cluster. And we have this cluster run, or this controller running on a 1-minute timer. So in a second, we should see that on the default cluster, it is uninstalled. And here, there's no chart on the default cluster, but on the Windows cluster, we still have it there. So now we can go ahead and add this back. And we're going to add it to all 3 clusters. So on the next reconciliation loop, it should see that all 3 clusters have the matching selector label and value, and it will go ahead and install the Helm release on all of them. So it might take a minute, but But the point of this is to show that we can easily select and unselect clusters that we want to have our Helm chart on. All right, I think we
There we go.
Yeah, I was waiting for that. All right, there we go. So we got the chart back on the default cluster when it wasn't here before. We can see that it's still on the Windows cluster. That was untouched. And if we look into the machine pool cluster, we can see that we have a release installed on there. And if we get the values, we can see that, again, it is the same CPU limits we had before, and it resolved the name of the cluster. So another thing that we can do is we can edit the Helm chart proxy. Did you have something you wanted to add, Jeff?
Yeah, would you mind while you're doing this, could you go to your tab on any of, I guess all three clusters are running the Helm chart now. Could you do something like a kubectl get pods -a -w, so we can see sort of at the Kubernetes pod level? And can you put a weight on that? What happens when these reconciliations? So we can see right there that there's several of those pods are under the enforcement of the Helm chart, like Cloud Node Manager, Cloud Controller Manager. But I expect what you're going to do is going to be to change the config, which should essentially refresh all these pods, and I think it'd be useful to see that.
Yeah, for sure. Also, Jack was the one who maintains this chart, so he knows it pretty well. Looks like my tab completion is a little slow today, but if we go in and edit our Helm chart proxy, we can say we we have the CPU limit is too high and we want to change it down from 10 to 2. So our CPU limit would be 2 plus the number of control plane replicas. When we apply that edit, we can see that the Helm chart proxy controller is kicked off again. And so on the Windows cluster, we can see there's a second revision here. On the machine pool cluster, there's a second revision here. And if we get the values, we can see that the CPU limit has changed. We go back to these pods.
There we go. I was getting nervous for a second.
Yeah, I think the wash just takes a second, but yeah, we can see that since we changed the CPU limits, our old pods are terminating, and we have a new Cloud Controller Manager creating, and we got some stuff pending as well. Do we want to wait and see for this to finish, or is there anything else?
Oh no, it is finished. I think it's just hard to interpret that in linear time. But yeah, I'm pretty sure that's the terminal state.
Okay, cool.
The goal state.
But yeah, if we get our pods, we can see that the Cloud Controller Manager just started up a minute ago.
Jonathan, do you want to take a question now, or do you want to wait till the end? The question in chat.
I can't really see chat right now.
Yuvraj, you want to unmute and just
yeah, sure. Hi, great demo. Can you also show the Helm release proxy CRD and the CR and what that is used for? I remember you mentioned that at the beginning.
Yeah. So yeah, why don't we pause and take a look at the CRD? So before we get to the Helm release proxy, another thing in the Helm chart proxy is that we have a status field. And this tab completion is slow today.
I can't even believe you try to use tab completion on Kubernetes commands.
Yeah, well, I don't think we have a short
Just,
name.
I pity your API server.
We'll use the back search. Yeah, so in the Helm chart proxy, we also have a status field that shows a ready status, and it also shows a list of matching clusters that you've selected with your label. So here you can get a quick glance at what you're actually targeting, and if you know, you selected something you thought you shouldn't have, or if something's not there that you think there should be, you can see that easily. So the Helm release proxy is more of a inventory CRD, but what's in here is that we have edit that. So this is essentially a wrapper CRD for the Helm releases we've installed. So we have a Helm release proxy for every Helm release we've installed. And since we have 3 clusters, we have 3 releases. So the point of this is that it gives us a way to know which Helm release is installed by us and if it's orphaned. So for example, if the user installed a Helm release out of band, we don't want our controller to pick that up and delete it because that's not something we manage. And if we orphaned a release, we want to be able to tell if we have some Helm release that would be dangling if we remove the label. So if we look into these Helm release proxies, the CRD itself, so for example, for one of them, it is pretty similar in the spec. It has a cluster ref to the cluster that it's installed on, the release name, the repo URL, and it also has the values field, which contains the resolved values for the cluster. So I guess a short tangent is that the Helm chart proxy controller is responsible for parsing out the values and creating the Helm release proxies. And the Helm release proxy controller, on a create, it just creates a Helm chart with these, or Helm release with these values, and on delete, it deletes the Helm release. Does that answer your question?
Yes, thanks.
Yeah, so there's not that much going on in here. It's mostly just for maintaining an inventory, but also for debugging, you can see what you've actually resolved. Because if you tried to reference something that didn't resolve to what you expected, you could also see what we're trying to install here. So going back to where we were before, I think the last thing we did was edit the Helm chart proxy. So if we go back on the default cluster, we still have our cloud provider chart at its 2nd revision. And something else we can do is I can make an out of band change to the Helm chart. So here the CPU limits are 3 last we checked, and I'm going to change it to 2 with this Helm upgrade. So we can see we've got a 3rd revision. We got the values out here. We've changed the CPU limit to 2. But all the other Helm charts are still on the 2nd revision. So I guess since we went over the Helm release proxy stuff, the Helm release proxy controller on its next reconciliation will see that this Helm chart on the default cluster has a value that doesn't match what's in the Helm release proxy spec. So it'll pick up on that change and do a Helm upgrade or a Helm revision to reconcile that change back to the desired state we've specified. And that's also on the 1-minute timer. So we can see that now it's on its 4th revision. And if we get the values, we can see that it's been changed back to what it was before. So we've shown that you can get the controller to make changes by changing the Helm chart proxy. You can get it to maintain the state of the Helm chart from out of band changes, but you can also get it to respond to changes in the cluster. So since we have our control plane replicas as one of the fields where we are resolving, I can scale the control plane replicas to, let's say, we'll change it to 5. And when I scale that, since we're using the number of replicas, it'll kick off a revision on the next reconciliation. Jack, did you have a question?
I just want to make sure Christian and Joel, who are demoing after this or who have topics for discussion, feel like we have enough time in 25 minutes.
Yeah, this is the last thing we have. So
okay,
I think we're almost there.
Cool.
So we should think it'll take a minute. All right, looks like something's happening. Oh, there we go. It's getting nervous for a second there. So we can see that we're on the 5th revision now, and we've kicked off the revision from our scaling of the control plane replicas. So if we get the values out, we can see that at 5 replicas plus 2, we have 7. And just to reiterate, none of these charts have changed. And if you want to uninstall all of them, you can simply go ahead and delete the Helm release proxy.
You mean the Helm chart proxy?
Yeah, the Helm chart proxy, excuse me. So in a minute, we should see that we are going to uninstall everything. So on the default cluster, we've uninstalled the chart. The Windows cluster, we've uninstalled the chart. And on the machine pool cluster, we've also uninstalled the chart. So that's all I have for the demo. And to summarize, our orchestrator for add-ons lets you dynamically install and configure your Helm chart based on the workload clusters and update it based on changes to the Helm chart proxy definition, the workload cluster definition, and the state of the Helm release itself. So this gives us a way to manage add-ons based on the Kubernetes principles of the desired state and the actual state, and also lets us do so for any number of clusters from a single point of control, which brings it into the cluster API design philosophy. So we are moving forward pretty quickly on this project. And since we're building it, if you'd like to influence the outcome of the prototype or the proposal, please check out the repo in the doc. Thanks, everyone. Are there any other questions I missed, by the way?
Thanks, Jonathan.
I didn't look at the chat.
None in chat, but feel
Thank
free. It's Christian and Joel, do you two feel comfortable that you have enough time?
For me, yes, it's just a very short point.
I can always defer mine.
Does anyone have any questions they want to ask? Okay, cool. That was great, Jonathan. Demo gods were very kind. Don't take that for granted next time. Christian, you are next on the agenda.
Yeah, I just wanted to shout out and say thank you to the Mercedes-Benz folks, which opened the pull request to contribute their implementation of the state metrics application, which follows the proposal which got merged prior to that. There's also an issue which outlines the steps to take afterwards, which are integrating into Tilt and implementing the missing metrics which are at the proposal. So yeah, feel free to take a look at it. Thank you. That's it.
Thank you, Christian. Give a second to see if anyone wants to respond. Okay, Joel, I think you're up.
Cool. So there was this load balance proposal which came around sometime last year, I want to say, which was originally driven by Jason. And the idea was around, what if we had this external load balancer type so that you could, for example, if you had a vSphere cluster running on AWS, use an AWS ELB, ALB with your vSphere cluster and kind of mix and match and basically separate the load balancer management from what we have today. At the same time, there was a conversation about the concept of having internal, external load balancer support. At the moment, it depending on platforms and stuff, obviously, like we only have one load balancer as far as I'm aware. Typically, that's external. So if you're on AWS, for example, your traffic goes out and egresses your network and then comes back in, which costs money. So there are these two topics which ended up in this huge conversation, which eventually kind of just died a bit. So what, like, I'm definitely still interested in the internal and external load balancer part of this. I wanted to see if there's still interest in the more generic load balancer CRD ecosystem and see how we can start reviving these conversations depending on what we are currently interested in as a group. So yeah, just kind of generally trying to gauge interest and see what we want to do with this project.
Yassine.
Yeah, so that one has been like going on for a while. I think like it's good that we're trying to make it to get some decision there. I think from the last discussions we've had, one of the issues we had with the proposal was that it was too complex in its current form, and it was like adding pretty much complexity to the current cluster API flows. I think one thing that we can do probably is see if we can enable, you know, the external and internal load balancer without actually like hampering any extensibility point, because yeah, I'd be worried like of building the abstraction now, given that we don't understand yet how we can build it. So if like, yeah, totally open, like if we can work on external and internal for now, since it's pretty much more concrete, while not blocking any eventual or potential pluggable model for load balancers.
Yes, I think that's definitely my preferred approach. I just know at the time, because the pluggable load balancer thing was going on, it was kind of just roped into one group. Yeah, totally agree. The current thing is very complex, and it seems, given it's not been pushed, that there just isn't a huge amount of interest in that anymore. So I'm trying to work out if that, wherever the original interest came from, whether that has died down to the point where we can say, okay, we'll keep in mind this generic load balancer pluggable thing, but for now we're going to push that off until someone comes back and says, hey, we really want this.
Yeah, I think that like that would be the idea. I don't think that interest died, but it's most that we would be doing a disservice to ourselves if we build something while we don't understand the use cases or how users will want to interact with it. I think external and internal is far more concrete, and we know like which use cases we want to accomplish through that. So yeah, definitely.
Cool, thank you.
Is there anyone present who can represent the alternate state of things? Because it sounds like Joel, you are, if you sort of take the reins here, and that's the direction. Just FYI, everyone, that's the direction it's going to take. So, Arun, you have your hand up, so go ahead.
Yeah, so I basically wanted to know if you could give us a 1 or 2 minute overview of what your thoughts were, like both options. And this is similar to what Jack mentioned just now. And also, if we are going to, so yeah, I mean, the reason why I ask is if there is going to be a CRD for a load balancer, then there needs to be somebody who implements the CRD and runs it in a Kubernetes cluster. And I was just wondering if you could have static pod like load balancers, which are actually created by the cluster when the cluster is coming up, if that would be possible, or if it had to be something outside the cluster. So yeah, I know. Thanks.
Yeah, so I'm not as familiar with the load balancer CRD ecosystem as the other part, but my understanding was that at some point the cluster doesn't exist. So we need load balancer management for the control plane, because that can't really be managed by the load balancer service controller. So I think it's something to do with that. I'm hoping Yassine has put his hand up because he knows more than I do.
Yeah, basically, like it's pretty much that. Like, so like the two ideas that we were discussing were like pretty much go full-blown generic, where we have like a generic CRD for load balancers, and then like an infrastructure specific one for each one that you want to implement. And yeah, very much like it can be either an in cluster load balancing, meaning like something like kubevip or static pod that is going to do this, or like something like ELB. Yeah, that was the first part, but this one brings a bit more complexity, because then you need to define how you're going to push down the control plane endpoint from the generic CRD to like the lower level resources, and how like users are going to interact to fill in their control plane endpoint, given what we have today, which is like cluster API reading from the lower resources and surfacing back the info to the generic resources. So this creates like weird flows where sometimes we're pushing down information, sometimes we're reading back, and like so far we didn't settle on like which one we would take, because we're not understanding yet which one would be like best from a user's perspective.
And just on the internal external, just to cover that, like it's quite a common pattern for people to have an internal load balancer and an external load balancer in front of their kube APIs, and then you can have things like the nodes go via the internal, and then it's just your kind of end users who interact with the external one. Obviously with cluster API, there's interactions from the cluster API management cluster into the guest cluster, at which point you then have decisions based on your network topology on which cluster API components should use which load balancer. For example, if you're say you're running your guest cluster and your management cluster in similar VPCs and they're paired, you could have it go via the internal load balancer rather than the external. But if they're not paired, then it needs to go via the external. So I think the internal and external, the complexity here is just identifying which components need which kube config, basically, the internal or the external, and having options for users to choose and configure that.
Sounds good. Thanks.
Yassine, is your hand still up?
Yeah, so I wanted to check like what would be the next step there. Probably like, I guess we need to pull out whatever we had for internal load balancers in the proposal, and like probably set up a new document dedicated for that, right?
So I have something for you. When this originally came up, I was asked to do the internal and external as a separate thing anyway. So
cool.
The HackMD I just linked covers the original like internal external requirement. That said, it was last changed a year ago. I also haven't read it in a year, so it may or may not be completely out of date. But in general, the user stories and the functional requirements, I think, are roughly filled in there. So this gives us a basis to work off if we are going down just the internal external route, though it will need updating.
Sounds good. Thanks.
Arun?
So yeah, I mean, I am new to Cluster API and the CNCF ecosystem, so I'm not sure how I can help, but I am interested in helping if something is needed. That is one. And secondly, I wanted to know if we could just implement a default software provider like CubeWeb for people who want to just say kick the tires on this, or add it to I mean, so that people could just try it out and use it without using an external load balancer. I mean, by external here, I mean using a hardware-based or an external software component.
So Joel, or sorry, Arun, there is a proposal open. So that's the most obvious way you can help in the near term, is to read that proposal, add your thoughts. Do you have a link to that? Joel, did you put, is that what that?
The HackMD is the internal external draft. I believe folks can comment on that if they wish to. And then
I'll paste a link to the Google Doc right now.
The Google Doc is for the more complex, full-fledged one.
Thanks.
All right, I think Fabrizio is next.
Yeah, to comment on this topic. So the first one, I kind of agree with Joel that we should not block one effort depending to the other. At the same time, if we go on with the internal external proposal, I think that we should add a paragraph or something that tells how basically this effort is not preventing the other to happen, or is not going in a different direction. So let's not block, but let's keep these in the horizon. Second, I'm pasting in the chat, there is a PR open trying to introduce to solve a problem that seems similar to me. Sorry, I have to send to everyone. So the PR is 3661. I kindly ask Joel to take a look and see if it is orthogonal or not to this work.
Cool. Yeah, the section where the crossover is an enhancement, very reasonable ask. I will make sure that we get that in. And the other issues, it's the end of my day here, and it's public holiday for the next couple of days in the UK. So I will get to this next week, but I will take a look. Thank you. Okay, I think I've got everything I need unless anyone has any other comments on this topic. Okay, thanks, everyone.
Lively discussion, great. I think we may be able to give folks 6 minutes back of their time. Great, thanks for everybody who contributed today. I will upload this recording to the YouTubes and reach out to folks.
Thanks.